Hello everyone, welcome to my presentation. My name is Parth and in this class I will explore the framework called TensorFlow along with the concept of machine learning and deep learning. Nowadays there is a lots of information available from many resources, but to make this information useful we need to apply a proper logic that automate the system to take decisions and behave intelligently. These are the topics in which we go through. For example, the definition of machine learning, deep learning, what is TensorFlow, history of TensorFlow, and some preliminary of TensorFlow. Then we visualize how to input data is processed that lead to the solution. That is the workflow of TensorFlow. Then we go through the architecture that builds the model in TensorFlow. After that, we learn about the components of TensorFlow, the properties of tensors and types of tensors in TensorFlow. Then we go through an example which visualize how to TensorFlow works in actual. After that, we talk on the platforms that can be able to run the model built by the TensorFlow. And lastly, I talk about the books which I referred through this presentation. So the first thing is to understand what is machine learning, or in short called ML. When a computer dig out information from a huge data without receiving external instructions, then we call the computer performing a machine learning. For example, in our day-to-day life, we receive email from various senders, but the senders which identifies as harmful, the computers automatically block that messages and move their messages to the spam folder. When we find a way to go somewhere, the Google Map automatically provides the best route to approach that place. When our internet recharge is near to expire, we get the notification reminder from the app. These all are the examples of machine learning. Now, what is deep learning? Deep learning is a software that mimics the network of neurons in our brain. That means it makes the network same as the network of neurons in our brain. When an application uses a network with multiple hidden layers, then it's making a use of deep learning that we will talk about later. What is TensorFlow? TensorFlow is a Google's powerful framework for developing applications that performing machine learning. TensorFlow is capable of handling big data because it takes input in form of tensors, and so it is called TensorFlow. Let us go through the history of TensorFlow. It is first developed by the Google Brain team and its stable version was firstly released in 2015. TensorFlow is an open source framework and is licensed under the Apache 2.0, which means it is free to use, modify and redistributable. TensorFlow is written in C++ languages. Now, we need some preliminary to use the TensorFlow. The primary interface for writing the codes in TensorFlow is Python. That means Python language is necessary to written the code in TensorFlow. So we need to familiar with Python in order to communicate with TensorFlow environment. TensorFlow also feature a utility called TensorBoard to visualize the graphs and operations performed on the data. Now we learn about the workflow of TensorFlow. TensorFlow takes an input in the form of multi-dimensional array or tensors which go through multiple operations and finally comes out as a result. TensorFlow allows us to construct a sort of flowcharts of operations which called as a graphs. Before proceed further, we need a definition called a node. Node is a data structure that keeps the tensor and the operations that performed on the data. This is the graphical representation of the workflow of TensorFlow. The input is stored in the nodes. The nodes which have the data in form of tensors and operators are transferred to hidden layer. Hidden layer process the data and the results transfers to the output layer. Here, the hidden layer is performing a very important role through the whole of processing of data. Hidden layer consists of large number of well-trained data structures in the form of nodes that are interrelated with each other. Processing the data in hidden layer makes use of deep learning. This is an abstract representation of hidden layer. A large number of nodes connected with each other in which each node contains tensor and operations. In a simple way, we tell that node contains a tensor or a operation, something like addition, subtraction, multiplication, division, modulus, etc. This is a block diagram of hidden layer in which several operations are done that lead to the final situation. Let us take input is go straight forward through the operation A and operation C. Now, the result from operation A and operation C will go straight forward towards the solution by using the operation D and operation B, means the composition of the various types of operations and tensors makes the results in TensorFlow. Now, we take a look of architecture of TensorFlow. Generally, TensorFlow done major operations like pre-processing the data, which sort of inputs getting from the various sources, that is the pre-processing the data. After that, it build a model. Model is in general the algorithm of the TensorFlow, and in last, TensorFlow train the model, means by using deep learning it optimize the model and estimate the built model with examples and correct variation if any. Now, let us look the components of TensorFlow. Mathematically, we all are familiar with tensor, but in context to TensorFlow, tensor is a vector or matrix of finite dimensions that represent all types of data in TensorFlow. Now, the shape. Shape describes the dimension of tensor. Now, the graph. Graph generally shows the structure of nodes and edges as the computation proceeds forward. Here, the edges are the straight line which connects nodes with each other. Let us look about the properties of tensor in aspect of the TensorFlow. Tensor requires a label or called a name, which is the name of the tensor. Secondly, it has the dimension which represents the shape of the tensor. And third, data type. Tensor have a various type of data types like integer, float, string, etc. Now, let we go through the types of tensor which defined in TensorFlow. So first is TF dot constant, which means this define constant tensor. Secondly, TF dot variable, which is used to define variable tensor. And after TF dot placeholder and tf dot spare tensor. But here tf dot variable, tf dot placeholder and tf dot spare tensor discussion is the beyond our scope. So we constrain ourselves to tf dot constant type. This is just an illustration of how tensor is represented in TensorFlow. Due to the software constraint, matrix actual is not appearing in the screen. Let's proceed further. Let's look how to create a tensor in TensorFlow. This is just what we talked recently. Something like a tf dot constant statement contains 3 arguments named as a value, d type means data type, and name. In both of throughout 3 arguments, the value shows the number of dimension of tensor. After d type means data type, this shows data type of tensor, something like a tf dot string for string data type, tf dot float 32 for float data type, or tf dot int 16 for integer data type. Lastly, name shows the name of the tensor. Now, running these codes shown in the box, we get the result in TensorFlow. This is a simple code to define a tensor in a TensorFlow framework. Now, by compiling and executing the code, we get the result in a single statement, not as actual tensor, although the tensor is already added. If we not give any name to the tensor, it automatically give a name called consto, means tensor of const 0, which is the name of the tensor, shape, which shows dimension of tensors, and d type means it shows data type. In our case, the data type is integer 16. Let us look at an example. Here, variable c is the resultant tensor of addition of 2 tensors called a and b. And in the second line, e is the resultant tensor of multiplication of 2 tensors called tensor c and tensor d. This is the simple operation we have to do in TensorFlow. Now let us understand workflow of TensorFlow, how it works in actual. So from the first line, the addition of tensor A and tensor B, which will be added in C. So in TensorFlow, the node A and node B, which is added in the intermediate operator called addition operator. Now the addition operator is now turned to the node C, or the first line shows C contains the addition of A and B, means the node is now known as C node. In the second line, multiplication of node C and node D, which will be added in the node E. So node C and node D, which will be added through the intermediate operators called multiplications, and that will be in turn we give as a result as a node E. So this is how the TensorFlow is work in actual as a graphical representation. These are the examples where TensorFlow can run. We can run TensorFlow in desktop PCs which runs on operating system like Windows, Macintosh or Linux. Secondly, Google is also provide a feature to run a TensorFlow program or TensorFlow algorithm as a web service named as a Google Cloud. Means we can execute or compile the TensorFlow algorithm as a web service in the Google's header. Thirdly, TensorFlow also runs on small mobile devices. Mobile devices runs on operating system like Android and iOS. Nowadays there is lots of research will be done, and it is further in proceed to learn called as a machine learning more on Android operating system. After that, it is also runs on Intel microprocessors and AMD microprocessors. This is the main environment in TensorFlow framework, which will be sufficient to run these microprocessors like Intel and AMD microprocessor, which is very tremendously power to handle this machine learning, deep learning, and called as artificial intelligence. TensorFlow is also runs on GPU called graphical processing unit. Recently researched that the TensorFlow algorithm can run on some GPUs like NVIDIA or called AMD GPUs. So this how TensorFlow broadening its work area, its usability and its compatibility throughout the use of these devices. Throughout this whole presentation, I used these references called TensorFlow for Dummies by Matthew Scarpino, and secondly I refer the book is TensorFlow by Krishna Rangata. So if you have any queries or question through this discussion, you can contact me through my email given in the bottom line. So thank you for your patience and become a part of the discussion. Thank you.